Hello everybody, we're going to talk a little bit about plumbing and mechanical requirements. This is part one of those. I want to kind of make sure you understand, if you've read through your textbook, you kind of know that the plumbing mechanical codes, there's kind of a separate edition that goes along with the IBC. And I've kind of showed you samples of those, which in the International Public Plumbing Code was first published in 1995. It's still updated every 3 years. And you can see I've kind of showed you the 2006 version. And then the International Mechanical Code is still published every 3 years. But then you will find that some jurisdictions use the NFPA and International Association of Plumbing and Mechanical Officials, UPC, which is published every 3 years, instead or in lieu of, or in addition to. So a lot of times you're going to have to ask the jurisdictions which one that they follow. But what you will find in these three codes that I've just mentioned here, the International Public Plumbing Code, the International Mechanical Code, and the Uniform Plumbing Code, you will find that the information there is kind of brought into the IBC code. It's just a little variances, but the plumbers themselves, or the HVAC people, mechanical people, have to use these other books in order to get exactly the sizes of the pipes, all the nitty-gritty that has to be done. But us as an interior designer would not have to do that. If you're in construction management, you may end up having to look at these other books or be familiar with them. Okay, typically mechanical engineers are required to prepare working drawings for design jobs over 5,000 square feet. In the state of Texas, that's kind of what we have to look at. Interior designers can create plans, architects can create plans, but if it's over 5,000 square feet, we have to work with an engineer. As designers, you're not going to be required to know or research the two code books, but you should be aware of a number of plumbing and mechanical requirements, such as we have to determine the required number of plumbing fixtures. If you're in construction management, you're going to still have to know to make sure that we meet those needs. Designer's responsibility is mainly typically design the space, the place of the fixtures to make sure in the right location, type of fixtures, be aware of plumbing chases and the access to those. Smaller jobs, as I said, may not require an engineer, but they're going to have to require a licensed plumber to be able to do what is referred to as shop drawings. The performance codes refer to the ICC performance code. A lot of times this day and time we have to look at our sustainability features, making sure that we're specifying, of course, and utilizing, especially if you're construction management, utilizing, of course, plumbing fixtures that are sustainable. And then, of course, accessibility requirements, selecting fixtures that meet the ICC and ANSI accessibility standards, and in the state of Texas, the TAS, or TAS, T-A-S, Texas Accessibility Standards, minimum clearances, location requirements, ease of control, use, and other accessibility standards. So, I just want to kind of make sure that you understand a little bit about plumbing systems. This part's really not in your textbook, but I think it's something that all designers should be able, and construction managers should know. You have three main components: a water supply system, plumbing fixtures, and the drainage system. And a lot of times that's called drain, waste, and vent, which the acronym of DWV. So we're going to talk about each one. Your drainage system, or drain, waste, vent system, consists of wide pipes since it operates on gravity. Yes, this is where all the water goes down the drain. You flush the toilet. This is called your drain, waste, and vent. starting at the plumbing fixture and ending up at the public sewer system, you're going to find out that this is something that you need to be aware of. At each fixture, there are traps that are used to discharge or to prevent odors, gases, and insects. You've probably been into sometimes a restroom, you think, oh my gosh, what is this odor? And nobody's used the restroom. That's because sometimes it gets very dry, not used enough, and so pouring water down a drain can help put water back into that trap. You're going to see that there's branch and stack pipes that are required to transport the used water from the trap to the sewer. And a lot of times you're going to see soil stacks that carry solid human waste, and waste stacks carry other waste. And then there's vertical stacks, which goes vents, penetrate through the roof of a building, allowing harmful gases to escape as water is discharged. So let me show you a visual. Okay, here we are in the diagram, and you're going to see that if we have a water closet or a toilet, as a designer or contractor, we call them water closets, you're going to see that there is a drain underneath those. Even under the sink, you see there's a little trap, and it goes, the tub, there's a little trap, and it all goes to this one soil stack. It's normally a 4-inch soil stack, depending on the number of fixtures that's tied to it. But you'll notice this soil stack, 4-inch, which is the darker line that's vertically going, goes straight up through the roof vent. So that's where those off-gassing is going through. You'll also notice that next to it a lot of times is a 1/2-inch vent stack, okay? Because you've got your sewer lines running. This is kind of your main stack of where the sewer is running down through here, but this is an additional vent stack that goes through here that's tied up through this roof vent for the off-gassing that's there. So in through here, you'll see where this is vertically sloped to go down to where your street sewer is. So street sewers, everything has to go gravity toward that street sewer. So when you're planning a building, you've got to go back and you've got to look to make sure that the street sewer line is lower than the house line if you're pouring a concrete slab, which you see. And a lot of times you have clean-out valves to be able to make sure that you clean out if anything gets trapped. In addition, you're going to have backflow valves that will be placed in here. That's one of the requirements that was done back in 2000. So if something happens to the street sewer and it starts backing up, there's a valve that's put in place so it will not go back up and get into your home. I've seen that happen before, where a home was built before that took place, and the city sewer stopped up and it backed all the way up into someone's home. Not a lovely sight. Okay, so this is kind of a closer version because I want you to be able to see this. This, of course, is what we're talking about, the trap that there's usually one at each of your fixtures. So it goes through here. There's a vent. It comes through and it's tied in to this particular stack, vent stack, and it's tied into your soil stack. But you'll notice that your drains, you notice how they angle down. That's where you have to have 1/4 inch slope to your soil stack for every foot. Okay, 1/4 inch for every foot. And this means that you're trying to plan out where your fixture is, may end up, of course, having this distance between when we get into our ceiling of our next floor. How far it is may make a difference on how big that plenum space, that's the space between the ceiling here and, of course, the floor from the other, the plenum space. And you've got to make sure you have enough area there for that to flow into the soil stack. So a lot of times in designing, you have to kind of take that into consideration. Water supply system consists of small diameter pipes that use pressure to convey either hot or cold water. course, when it comes from the street, and you'll notice that when you're in the street, you have the water line is always above the sewer lines. That's so that the water is never, of course, contaminated. First is the main water line, which brings the water into the building from the public water system. Once it's in the building, it's split into two distribution lines. One leads directly to the plumbing fixture, because there's some plumbing fixtures that only needs tap water or cool water, okay, which like your water closets, toilets, things like that, you would need hot water. But then the other one leads to either a water heater, or it could be to a tankless heater, and then it's distributed to a fixture, because our sinks, dishwasher, other type fixtures need, of course, hot and cold water. The system is controlled by valves both at the entry into the building and at each fixture, so that way you could cut or turn the valves off at the fixture if you needed to stop if there was a leak at the sink, or at the leak at the water closet, or a leak into the whole home. You could turn the valve off and it would stop the water from flowing. Okay, we talked a little bit about, we said either a hot water heater or a tankless water heater. Well, this is kind of showing you how a tankless water heater works. A lot of times, most of them are gas operated. There are some electric ones, but they're that is not near as efficient as it should be, but these are gas operated ones. And what it is, it's usually mounted on the exterior of the home. It has to be well vented for this. But you can see how, here's the gas line that's going into it, so you can see where the burner is. Notice that. And then the cold water is coming into it. And so it waters, the water enters the heater. The water flow then sensor dictates that there's water flowing through. So this computer automatically ignites, that you see, the little green computer part, ignites, and the water circulates through what is referred to as the heat exchanger. And the heat exchanger gets the water hotter and hotter and hotter, and then, of course, it goes through a valve, and it goes to the fixture itself. So that's how the tankless water heater works. When we have a hot water heater, it works kind of the same way. But what this is this is all water that has been heated. It's like putting a pan of water on top of the stove. And so it stays warm. It stays a certain temperature by what you set the hot water at. And so if you'll find that a lot of times you run out of hot water because this tank may not be big enough, and so therefore there might not be enough water. Just like if you're trying to make hot chocolate on the stove and you only have so much water in that pot, you've got to try to go through and make sure that you have sufficient. So sometimes you may have to wait until your water heater reheats more water for you to be able to look at it. Now, hot waters can be gas, and if it's gas, it has to be well ventilated. You'll find that if it's in the interior of the home, there is another valve that goes through the roof, and it's ventilated to the exterior part, so there's no gas that goes through. If you see that you put a hot water heater in your garage with the ignition, okay, any type of ignition, the height cannot be less than 18 inches, because that means gas is coming in, and if you were to drop gasoline on the floor, it would go right to those, and the fumes would ignite and start a fire in your garage. So therefore, it has to be raised. Your hot water heater has to be installed up at least 18 inches AFF. That's above finished floor. So this is showing you a diagram of a water supply system so that you can see here. I wanted you to kind of look at this because when I worked in restaurant design a lot, we would have to do diagrams so that we would show the plumber where the hot water lines were coming in, where they're not coming in, where the cold water lines are, valves, check valves. You will probably never do one, but I want you to at least be exposed to that, because all of these lines are coming in, remember, from your main sewer line, and these are cutoff valves that are used, and it goes through a meter. You see where the M with the circle is a meter, and then you see T turned up, T turned down, elbow turned up. This is, of course, where it's going through and turning up in either a wall, or it's turning up and coming up through the slab to go to a fixture, appliance, or a hot water heater, one of those, and then T turns down to go back into the slab, so from the hot water heater to the other appliances. So it's just showing you how one works and looks. Okay, plumbing fixtures are kind of the beginning of the drainage systems. And we know fixtures are the end source for the water supply. Consist of water closets, lavatories, urinals, sinks, drinking fountains, bathtubs, showers, dishwasher, clothes washers, and any other miscellaneous fixtures that you might have, like a hose bib or something outside. There are some pictures of plumbing fixtures. So, one of the things that you have to do is make sure you understand how that water comes into that fixture and where does the drainage go out of the fixture. So a lot of times you have to do research to know what the shape of the fixture is, where the water comes in. Here's where the water comes in this particular fixture. You can see it on the wall here, and it goes through, and then it enters and goes through the floor. So knowing the dimension, because that means that's where you have to make sure that it states, if you're designing something, how far do you have to have that particular plumbing fixture from the wall. Sinks are the same way. Where does your water come in? And you can see the circles up at the top. And where do your drains need to be placed? They may be not side by side. They may be at an angle or different types. You may have one sink that is deeper than the other side. So that may make a difference on where your drainage is placed and where it's going to be turning back into the wall. And that means your cabinetry that you design may take on a different flavor because you can't put what you wanted to under the sink. One of the things I want you to do is I want you to go to the website of Kohler, Kohler.com, and I want you to look at all the different specs that you have. So go to kitchen, bath, Kohler, bathroom, elongated, and I want you to look up Persuade, Circ, Comfort, and then I want you to look through the specs. I want you to pick a color, tell me the list price of that fixture, tell me the water conservation features, give the dimensions, price, features that go along with it, color options, download the dimension sheet. Okay, because you're going to learn that sometimes that some of the fixtures that you select comes in two different components. Sometimes it comes where it doesn't even have a flush valve, and you've got to spec that. Some of your water closets do not even come with a seat. So you've got to make sure that all of these components, what you're specifying, is all put together. Then, in addition, I want you to locate a sink and give all the same information from it. So I know the manufacturer's name, the product number. I want you to tell me the colors that you can get it in, the list price, the water conservation features, anything like that that you can see, and download the spec sheet. And you will see that there's assignment in Dropbox for that. So, kind of to review, specification sheet, excuse me, with dimensions. The page, name, number, product, water conservation features, give dimensions, features, color options, etc. Then do the same for a sink. Identify the sink name and number, etc. This is just an example of what the Adair, looking at it, because you're going to find one-piece toilet. It may be one piece, the tank and bowl into a seamless. It talks about it. It's elongated. It has 1.28 gallons per flush. And so sometimes some jurisdictions may have real strict restrictions on how many gallons per flush you can have, which is the GPS. And so you've got to make sure that jurisdiction, sometimes like in California, some areas that have a real hard time with water, they're going to go through and look at these kind of things. So you've got to make sure that you are meeting the needs of that jurisdiction. It's going to tell you if it's a left hand trip lever or right hand. That may make a difference on your design. So you have to look at that. So it's going to be a standard installation, the rough end. So you would go back and look. A lot of times you see, if you see the symbol WaterSense, that kind of gives you an idea that it's more sustainable and uses less water. So I hope this has helped you so that you could go through and kind of start on specifying plumbing fixtures.